So today we're going to do a kind of a different kind of graph than we've been doing. They're called qualitative graphs. Qualitative, think of the word quality versus quantity. So we're not going to be seeing sort of numbers on our graphs the way we had been. It's more, well, let's put it this way. They're called story graphs. So what becomes really important are the labels and the title and understanding what's happening as different parts of the graphs change. So I'm going to start in the book on page 347. And we're just going to see here a table. And we are going to make a graph with numbers on it. And then I'm going to take them off and just show you how you can sort of see basically what's going on in this situation. So Emily is downloading photos from her digital camera onto her computer. Just think of basically downloading anything. And the table shows the percent of photos downloaded for several seconds. So as time goes by, more and more photos are being downloaded. But have you ever, downloaded a movie or anything, and all of a sudden you kind of end up in that buffering, kind of waiting, slowing down kind of thing? So it's not necessarily linear. We're not going to see that same constant rate of change. So basically what I want you to do is look at the table, and you're going to see time as your, X here. So 0, 2, 4, 6, going up by 2 seconds. But notice on the other side that things sort of change as we go along. It doesn't stay the same. So the first question asked, during which period or periods of time did the percent download not change? So take a look and see if you can find between what time periods, like 2 to 4 seconds or 10 to 12 seconds or somewhere, where did the download sort of stall, for lack of a better word? Did you notice that it happened in two places? One was from 4 to 6 seconds, where it kind of got stuck at 30% downloaded. Kind of like I said, if you don't download photographs, you could think of like a movie or music or something. And then it happened again at 8 to 10, where, after 8 to 10 seconds, it got stuck at 64%. Now they want you to look back at the table. And was the fastest? When was the interval of time, couldn't think of the word, where the percent downloaded the fastest, the most? Take a look again, see if you can find that. Now that happened between 6 to 8 seconds. So again, if you're thinking about slope, you would see for these 2 seconds, it was a 15%. So 15 minus 0 over 2 minus 0, 15 divided by 2. It was downloading 7.5% per second. Same thing here. You would get 15 divided by 2. Here is where it stalled. But when it went from 30 to 64, it jumped up 34% in just 2 seconds. And 34 divided by 2 is 17%. Got stalled again. And then if you look here, this would be, let's see, 6 to get to 70, so 18% if you take 82 minus 64 divided by 2, so that's a 9%. And then here we've got 18 again, 100 minus 82 divided by 2. So the biggest jump, sort of like after it stalled here, it jumped up 17%. And that's the math that I did to get that. So if you look at number 3 on page 37, what you want to do right now is just go ahead and plot all of these points on the graph. So we're going to stop sort of the video, plot the points, and then we're going to talk about it a little bit. Okay, so let's take a look. This is sort of how your graph should look. Mr. Yuck's here because once again, our book has forgot to put the title, so I put Emily's downloads. Time, so this is 2 seconds, 4 seconds, 6 seconds, and 8. Remember, if time's involved, it's usually X. We've had that conversation a lot. And here's your percent downloaded, and you see me plotting the points. You can see right there the stall, that it got stuck at 30%. You can see here the jump. The fastest download, notice that look at this line segment, look at this segment, and look at this segment. Notice he's the steepest. He has the steepest slope. He went the fastest. Here's that second stall, right? So if you kind of look here, if we were to take the numbers off, which is what the book's doing on page 348, they just took the numbers off. You can actually kind of, without saying specific numbers, you can say, well, the percent download was going up linear, and then it stalled. All of a sudden, as time continued, no more was added on to the percent downloaded. And look at this steep piece. It shot up here and stalled again. So even without the numbers, you can see the relationship between the time and the percent downloaded. So qualitative graphs may not even include numbers, but given the title and the labels, you can kind of tell the story of what's happening. Really important that you need to have these labels in the title, though, to be able to tell what's happening in the graph, even though there are no numbers there. So here's a graph. You can see no numbers. Again, the book doesn't put a title, but in the description, it's going to tell us the graph at the right displays the water level in a bathtub. So, I would have put a title up here that would say water level in a bathtub. And what we want to do is describe what's happened over time. So even though there are no numbers, as you move to the right, time is going by. And as you move up, the water level is getting higher. Okay, so right here is where we start. And at 0 time, there's no water in the tub. Well, there's no water in your tub, probably at home either. So you turn on the spigot, you turn on the faucet, and the tub starts to fill. You can see at a constant rate here. And then it gets to a place where you turn the faucet off. And now it doesn't get any higher. And then you pull the drain and it decreases back down to an empty tub, back to a water level of 0. So you basically turn the faucet on, you turn it off, you pull the plug, it drains. So increasing, no change, decreasing in the water level. So take a look. We're not even going to look at B. It's kind of a horrible example. So you're going to see I just kind of put it, just cross it off. But in A, the graph at the right displays the temperature throughout the day. Again, Mr. Yuck's there because there's no title. So, if I had just put that title in, I could actually, without even reading this, kind of know what's going on. So I slid that title in. So the graph at the right displays the temperature throughout the day. Describe the change in the temperature over time. So what's going on in this graph? Did you say that the temperature is going up and then maybe midday, the temperature peaks and then the temperature is going to drop as you head towards, nighttime and evening. So the temperature rises until the hottest part of the day, in the summer, maybe 1, 2 o'clock in the afternoon, and then it's going to drop off until we get to dusk and evening. That's all you have to do. So this one isn't in the book, so I'm just going to give you another one. Notice there's no narrative here, and can we tell a story about what's happening without any numbers and without any words other than the title and the labels? So I'm going to read the title, A Trip to a Friend's House. The x-axis, as we go to the right, time is going to go by in hours. And as the graph goes up, as these lines change up, that's my distance from home in miles. So what is happening in this first piece? What is happening to my distance from home from here to here? Did you say that you're leaving home and going to your friend's house? Absolutely. That's what we're doing. Notice it's an increasing piece. We're going away from home. Home would be right here. And as we go up here, we're going away from home. What's happening in this second piece? Notice that time is going by, and look what's happening with our distance from home. It's kind of flatlined. Did you say that that's the part where you're at your friend's house? Your distance from home isn't changing. So that's where you're at your friend's house, playing video games or something. Okay, notice the third piece. And there's really 2 things you have to address here. What's going on as it decreases? And why is the slope here? Why does it take so much more time to get to your friend's house than this piece? So there are 2 things here. One is you are returning back home, but you're at a faster speed. It takes less time to go from your friend's house home than it did to get there. So there's all kinds of explanations, and any one of them could be good. So maybe you walked to your friend's house and your mom picked you up and drove you home. Maybe you walked to your friend's house, realizing you were late, you ran home. But somehow in your story about what's going on, you have to include the fact that you're returning to home And why are you returning faster? Maybe you borrowed your friend's bike to drive home because you knew you were going to be late. So step one is a slower speed than step three because the same distance is taking longer in step one, more time. So identify the graph here that displays the altitude. And altitude would be your distance from the ground, okay? So it's just your distance, but up in the air, of a skydiver as he is taken up in a plane. He jumps, free falls through the air, and then opens his parachute. So which graph here would be the graph of that story? So first of all, notice C, you're starting at already off the ground. So this one said that, you were taken up in a plane. So both B and C are starting at time zero already in the air. So it has to be one of these two to be taken up in a plane. So if you notice here, you're taken up in a plane, then you're out of cruising, then you drop, go kind of quickly, and then you slowly continue your trip down. This is the skydiver. So here you were taken up in a plane, you were at a steady speed, then it looks like you went up some more, and then you're at a steady speed, and then you go down to the ground at the same rate all the way down, which this point right here is you're pulling the parachute, which will slow you down as you head to the ground. So A is the right choice. Some people try to pick this one because they think that when you pull a parachute, you go up because every time they see it on TV. But what you're not taking into account there is you never go up with the parachute. It slows you down. And what makes it look that way is because the person with the camera continues to move down. So it makes it look like the person's rising, but they're not. Okay, which graph here would represent somebody going outside and pulling the cord and raising a flag up the flagpole in the morning? Which one of these would be that? So first of all, A is it instant, like with no time going by, it goes from the ground up, like no time goes by, boom, there, like magic. This one has the height the same over time. It never goes up, it never goes down. So the question is, which one of these? So D would be a manual. You pull it and then it stays, and then you pull the cord and then it stays, and you pull the cord and then it stays, and then it gets to its height and stays. This one says that it's going up at the same rate. And if you have like out in front, the manual pull, somebody pulling it is going to stop to reach up and pull again. So it would actually be D. If we go to page 349, there's a couple more examples. So they do the tennis ball drop. So a tennis ball, again, title's missing. Hold out a tennis ball and just drop it. And when it drops, it doesn't bounce back up to your hand if you just drop it. You would have to like kind of throw it at the floor with force. But if you just drop it, each bounce will get shorter or at a lower height than the one before. And they want you to sketch that in here. So you'll see right in example 2 that they have this example that it starts in your hand. It's not at the ground. It starts in your hand and it drops and it bounces up, but it doesn't go as high as your hand. And each bounce has it going lower and lower until eventually it'll just lay on the floor. A couple things to notice about this graph is that it's not spiky. It doesn't immediately go down. If you've ever watched the ball when it bounces, there is this slowing down, like a deceleration before it turns around and goes back down again. So the ball slows to a stop and then accelerates as it falls back to the ground. It doesn't go up and down and up and down. So just that would be more of a curve, not this little spiky guy. Okay, number 3, I always love this one. A child swings on a swing. Sketch a qualitative graph to represent the situation. So here's our swinging child. Again, title missing, time's going by, and this is the distance from the ground, right? So first of all, you're not sitting on the ground. So notice that at time 0, there's the height of the seat off the ground, and then you're going to swing up, and you're going to swing down. And just like the ball, there's kind of that slowing feeling before you go in the other direction, and up and down. And notice that each successive one, the child is pumping and getting higher. Very important to notice that never are we hitting the ground. The swing seat, you're staying off the ground. If this was hitting the ground, that would be a trip to the emergency room, basically. So the swing does not reach the ground. And they're kind of a picture just to kind of remember that that's what's happening. So you go up and then you come back down to the, the level off the ground that the seat is, and then back up. These are all called qualitative graph. No, we're not talking about any numbers. We're not talking about how high somebody went. We're just talking the story of what we see on the graph. So I thought I'd change the word this time. We've been doing a lot of distance, either distance from the ground or distance from home. So this time we're going to change it to speed. So miles per hour, how fast you're going. So again, as you go to the right, the time is going up in minutes. And as you go up this time, you're speeding up. A flat piece means you're going a steady speed, where the flat piece, remember on the distance to your friend's house, that flat piece meant you weren't traveling anymore because this label said distance. Because now it says speed, a flat piece means you're going at a constant speed. And as you go up, you're talking about increasing speed. And again, flat speed going up. So when it's flat, you're going a constant speed on a speed graph. So I don't know if you've ever been skiing. So let's just tell a story here to imagine what's happening in this graph, and it's called the last run of the day. And what we see is this piece right here, constant speed over time to start the run. Can anybody who's been skiing think of what that is? I'm hoping somebody out there realized that that's the ski lift, the chairlift. So as you go up on the chairlift, it goes a steady speed. Now notice that this piece is going up. On a speed graph, that means we're speeding up. So when you get off of the lift, there's a little hill that will cause you to move away so the next chair doesn't come and like hit you. So you go faster. So even though it looks, hey, it looks like I'm going uphill, you're not, you're speeding up on a speed graph, okay? And you speed up until you're going at a steady, faster speed than the lift. So you're moving now as you went down that little hill, you speed up and now you're moving along at a good clip, and you pick which trail, your blue trail, and you go over the lip and you start speeding up until you go back and forth, kind of hitting a comfortable speed as you go down the hill. All of a sudden, if you look here, something changes. So let's just go back and remember that this was the ski lift. And then we sped up as we got off the lift to a constant, comfortable speed. We sped up as we started to head down the slope to, again, a comfortable kind of back and forth speed at a steady speed going down. What happens in this F piece? It is a rapid increase of speed. So maybe you're out of control. And then what is this? From here right down to here. What just happened? That was a rapid deceleration. That means to slow down really fast. And it probably means you just fell or hit a tree, unfortunately, or something, but you got going out of control and you're speeding up, you're speeding up, you're speeding up, and boom, you instantly go to a stop. So likely you've just met the ground. So having said that, let's look at page 350. Can you do one more? But this time it's a car traveling at a constant speed. The car, so it starts off with a car traveling at a constant speed. The car slows down steadily to come to a rest at a stoplight. Sketch a qualitative graph to represent this situation. Can you open up to page 350 and go ahead and do that graph? So title, labels. So this time you're going to have speed as your Y. You're going to have time as your X, as always. And your title might be stopping your car or something like that. Oh, car stopping. So you already had said we're traveling at a constant speed. So on a speed graph, so this might be like 40 miles an hour, and you're going 40 miles an hour, and you're going 40 miles an hour, and you see the stoplight. So you hit the brakes and you start to slow down until you come to a stop and your speed is 0. Really easy little graph, but there's your constant speed. And then there's your deceleration, which means slowing down until you get to a stop. So today we've just kind of done some different kinds of graphs that don't feel as I guess precise, but they really help you start to look at what's happening in real world graphs. So what's really important? A title. Also important are your labels. Notice a qualitative graph doesn't necessarily have numbers, and you're just talking about, oh, you're speeding up, or you're slowing down, or you're going at a constant speed, or you're moving away from home, you're not moving at all, you're going back towards home. Those are the type of things we're talking about. Oftentimes students have actually kind of fun with these graphs, and it helps you just to be a little bit more intuitive and understanding of kind of real world graphs. So I hope that this made a little bit of sense, and that when we get together we can practice a little. Until then, have a great day.